Okay, cool. Thanks, Ratu. Hello, everyone. I hope you're enjoying the workshop so far. And my name is Xiangfeng, and I'm a second-year graduate student here at UW. And to make what Danyang and Ratu's talk more concrete, I want to show you how ADN and mRPC work in action. So the outline of the demo is the following. First, I will do a quick overview of the ADN abstractions, and then I'll move on to some examples. And finally, I want to show you a live demo of a simple client-server application. And our applications in this demo are built with mRPC as the communication library. And before I start, I just want to make a disclaimer that we have not implemented everything yet. And some of the component I'm going to show you is kind of fake. For example, we do not have the compiler. But I do hope to give you a sense of how they will work once we have everything. So we view the communication between each pair of microservices as a graph of elements. And elements here you can think of is similar to envoy filters in some sense. They process a single function on the input RPCs, which this function is defined in a SQL-like DSL. The workflow of each element is shown in the bottom left figure. The input is a list of RPCs, which we model as a table. And the element consists of some internal state and some processing logic. And finally, it generates an output table, which is passed on to next element or the transport. And the bottom right shows you the example we'll use in this demo. We have a read limiting element connected to a logging element, followed by an ACL element. In other words, access control list. This line shows you how they're initialized, but let me show you how they're implemented. So for the ACL elements, we have an internal state, which is the ACL table. It stores the names and permissions. And on initialization, we insert a bunch of records into the table. For the demo purpose, we'll have two records. We're going to block all the requests from Apple, but we're going to allow all the requests from Banana. And the process logic is just to block the users that do not have permission. We achieve this by using the join two tables together and using this where clause. And for the logging, it also has an internal state called RPC events. And the processing logic is basically you insert an event for every incoming RPCs. And then it simply forward all the RPCs from the input table to the output table. And I will skip the read limit for the sake of time, but it's implemented using the token bucket algorithm. Okay, let's move back to the slide. Let's imagine for this set of elements, the controller initially decide to put read limit and logging on the client side. But the ACL is placed on the server side because you can imagine the client is limited on resources. But as the client has more resources, it's ideal we should move the ACL to the client side to save some bandwidth or CPU usage since it's dropping some requests. Now the question is, how do we transition from scenario 1 to scenario 2? Since you cannot atomically move the ACL, there are two potential approaches. In the first approach, which we term the safe version, you first add the ACL to the client side, and then remove the ACL from the server side. This is safe because there is no policy violation during this migration process. However, naively, someone may decide to first remove the ACL from the server side and then add the ACL to the client side. This is unsafe because during step 1 and step 2, there's a window in which some requests that should be blocked slip through, and we have a policy violation. So the job of the ADN controller is to analyze the element definition and based on the semantics, make sure only the safe version will apply. And before I show you how it works in action, let me quickly walk you through the ADN controller workflow. It is similar to the existing Kubernetes controller like the scheduler, in which it watches the resource changes and especially the customized resource we create called ADN config. And based on this config, it simply runs a reconciliation loop and update the mRPC engines. And let me show you before I show how it runs, I want to show you the YAML file, the configs I will apply. So this is the config file for scenario 1. And we have a client and server. And because we do not have the controller yet, we have to manually say read limit and logging is applied to the client side and ACL is applied to the server side. But you can imagine with the controller, we don't have to do that. In other words, it's all automatically handled by the controller. And in scenario 2, we move the ACL to the client side. So let me switch the terminal. I have 2 terminal here, shows you the log messages, and then I have one terminal which I'm going to type the commands. So let me first, 1 second, let me try to set up this thing. So I will first create the client and server, which is going to start in a sec. So it is connected. So how it works is the client is constantly sending some requests to the server. In this case, we have 2 types of requests, apple and banana. And the client will, for every 4 seconds, it will print the log messages showing the request count or request and response count. And here you can see there are 20 requests per 4 seconds. So the request rate is roughly 5 requests per second. And now I will deploy the ADN control plane, and which is gonna take a little bit time to start. Okay, here you can see it's connected. And now I will apply the safe version, which here applies scenario 1. You should see those 3 elements or network function kick in. So you can see the request rate has dropped, and then all the Apple requests are blocked. And now I'm going to apply the scenario 1 config, which is going to migrate the ACL from the server side to client side. And ideally, you can also see the controller is running a reconciliation logic. So ideally, you should not see any any policy violation, and you should see the request rate stays the same, and all the Apple requests are blocked. And now I'm gonna delete the configs, so you should see the request rate start slowly ramping up, and the Apple requests are going through. And let's next see how the unsafe version look like. So I'm gonna apply the same scenario 1 config. Again, 3 network elements should kick in pretty soon. And I'm gonna have a special config, like kind of like you can think of as a switch that turns off the analysis of the controller, which means it's gonna first try to remove the ACL from the server side and then apply it to the client side. So this is how I do it. This like you think of like a switch that turn off. And once I apply it, you should see, yeah, here you see there's a policy violation, like Apple request that slips through, but during this migration process, but this really shouldn't happen. And then now I can delete all the configs. You should see the again, the request rate go back to normal, and then the Apple request is going through. And with that, I'll conclude my demo, and I'm happy to take questions if there's time.